In our last lecture, we discussed about the steps in hypothesis, and now we are proceeding further towards the one sample t-test. In steps of hypothesis, we discussed that we have to first define the statement of hypothesis. Like our example was about whether the mean blood pressure is equal to 120 millimeter Hg or not. And then corresponding to this hypothesis, which we regarded as null hypothesis because it contains the equality, we define another alternative hypothesis, which is mean it will not be equal to 120. So then we define the level of significance, which we take alpha is equal to 0.05, which is nothing but the type 1 error. And we usually take it as 0.05, and the other values are 0.01 and 0.10, and other, but not more than 0.10. And then we have the test statistic, which is based on type of data and statistical hypothesis. From now on, this is our major concern of discussing because for different kind of data we and different kind of statement hypothesis we have different test statistics. So then we define our rejection region, that we will reject the null hypothesis, which is defined in step number 1, that if p-value is less than equal to alpha, this alpha is defined in step number 2. So we will reject the null hypothesis if p-value is less than equal to alpha. And then we compute in any statistical software. Our concern is mainly on the SPSS. And then and based on all these steps, we make the conclusion that whether the p-value is less than alpha or more than alpha, and then based on the p-value and the result, we make the conclusion what is whether the statement or hypothesis is true or not true. So for considering the one sample mean comparison example, understanding that, so we are discussing two examples. For first example is that the following data, this is the data of the 10 students which represent the internal evaluation marks of biostatistics obtained by 10 postgraduate students of previous year. It is stated that the postgraduate student in general obtain an average marks of 20 out of 30 each year. So we have to test the hypothesis that last year's student, that is these 10 students, also acquired the same mean score, which is 20, which is the hypothesized value. So here, our we have to define six statement, like a statement of hypothesis, for which we are measuring that testing the average marks of student is in quiz was 120 or is 20 or not. So we will make the null and alternate hypothesis based on this statement. Then we will define the level of significance, which is not given in the data, but if it is not given, we take as alpha is equal to 0.05. Then we decide the test statistics, and then we define the rejection region, and then we compute using SPSS, and then we make result in conclusion. So here we go. Our null hypothesis based on the statement that average marks of student is 120 is 20 or not. Our mean is equal to 20. It will be our null hypothesis because it contains the equality. Versus we have the alternative hypothesis which imply mean is not equal to 20. This is our alternative hypothesis, just contradictory to this statement. Our second step is level of significance, which is not given, but we will take alpha is equal to 0.05. It is most commonly used. Then we have to define the test statistic, for which we have to see the type of the data and the statement of hypothesis, which we are going to study in our next slide. Rejection region is that when it's the statement that we will reject the null hypothesis if p-value is less than equal to alpha. Then we compute it, and then we make the resultant conclusion about based on the above steps. So this is the step number 3 about the test statistics. When we have the quantitative variable and it follows normal distribution, and when what we have to do is we are going to compare the mean of the sample data to the hypothesized mean. We use one sample t-test. The theoretical difference of the theoretical definition of the t-test is not covered in this lecture. We are just working with the practical application of the hypothesis. So We have the quantitative data which is being compared with an standard value which is 20. So the test setting, we are going to use one sample t-test. So and then we are using the SPSS. So option is to compute, we have to use analyze, compare mean, and one sample t-test. So in the SPSS, when we go to the analyze, compare mean, and one sample t-test, a dialog box appear in which we have to transfer the variable which we have entered in the data, and we have to specify the value of 20 in the test value, which is our hypothesized value. Then you press OK, and after pressing OK, we obtain in the output file two a table. One is descriptive statistics, another one is our outcome of interest. I mean the table of interest. What we have done, we have compared this sample mean to the our test value, which is 20 also, and where is the p-value in this table is actually in any software whenever you find the sig value, because the it is a p-value because this is the observed significance level, and what we have obtained is 1.000, which is more than 0.05. So this is a software which is displaying the p-value as exactly 1.000. So but in statistical theory we do not, this is p-value is the probability. We do not write that it is 1.000, we write it as p-value more than 0.99. So p-value is more than 0.99 from our data, which is more than alpha, which we set at step number 2 at 0.05. So we have to reject the null hypothesis if the p-value is less than equal to alpha. But this time we obtained the inversely, that p-value is more than alpha. So we fail to reject the null hypothesis and conclude that the average marks of students remain 20 each year. And this is the statement which we have made so far based on the description in the result. Another example is that about the sleeping hour of the student, of the college student. The hypothesized statement is that every sleeping time is supposed to be 8 hours a day. And they think that the university students sleep a different amount, maybe more or maybe less than 8 hours. So what they did, they surveyed 10 students and they obtained that they asked um, their sleeping hour. This is the data of the students, of the 10 student, like someone slept 6 hours, someone 4 hours, someone 6 hours, 7 hours, etc. So now we have to check whether the data supports our null hypothesis that the sleeping time is 8 hours or not. Again, we have to follow the sixth step. Like the first statement is about mu is equal to 8, like sleeping hour is equal to 8, and the mean sleeping hour is not equal to 8. Then we have to define the level of significance, which is not defined in the lecture, in the question. So it means alpha is equal to 0.05. Test is the one sample t-test. We will reject the null hypothesis, p-value is less than equal to alpha. We will follow the same procedure, like we will go analyze, compare mean, and one sample t-test. In the one sample t-test, the dialog box appear, the sleep value is entered. We will transfer the values at the in the box sleep time, and in the test value we define that it is equal to 8, with the hypothesized value is 8. We press OK, and after that computation, the output will appear in the SPSS output sheet. And the p-value, this is the descriptive statistics of the our data, and the p-value is here, the sig, which is which by software display at 0.000, which we have edited at 0.0 less than 0.001. So if the p-value, the result is that the p-value is less than alpha, which is 0.05, divided in the second step. So the conclusion is that sleeping time of students shows statistically significant different from hypothetical mean, because we reject the null hypothesis that it is not equal to alpha so far. So this is our practical application of t-test when we are working with the hypothesis. So in the two lecture, what we have obtained that we define the comprehensively null and alternative hypothesis. Then we define the level of significance. When it is not given, we took 0.05. Test statistics is based on type of data and the statement hypothesis. Our type of data was quantitative and we have to compare the mean. So we applied the one sample t-test. And the rejection region is general. Like reject S naught if p value is less than equal to alpha. S naught is the null hypothesis. Computation we did from the SPSS, and then we have to make the resultant conclusion. Like in our internal evaluation marks, we had p value more than alpha, so we failed to reject the null hypothesis. Then in our sleeping time example, our p value was less than alpha, so we reject the null hypothesis and make the conclusion. So this is our lecture so far regarding the one sample t-test value. See you in next lecture.